Back at you here with day 63. I'm going to take a look today at problems 4 and 6 from the review sheet, getting ready for Thursday's test. Problem 4, what we know is we know that h of 6 is 12. We know h prime of 6 is negative 2. We also know that h double prime of x is less than 0. Okay, so we want to approximate h prime of 2. Or sorry, h prime, or sorry, we want to approximate h of 6.2. Okay, so again, we want to get a tangent line here. To get a tangent line, we need a point and a slope. Well, those things are really obviously given to us here. The harder part of this problem is then, is this an over or under estimate? That's the second part of the question. Okay, so first, let's crank out the answer to our approximation here. So I want to write an equation of a tangent line. So obviously I need a point and a slope. My point is the point 612 that I get from right here. X value 6 gives a y value of 12 on h. My slope then is the derivative at 6, which is negative 2. So writing my equation, I got y minus 12 equals my slope of negative 2 times x minus 6. To approximate h of 6.2, I'm going to plug in 6.2 for x, and I got y minus 12 equals negative 2 times 6.2 minus 6. 6.2 minus 6 is 0.2, positive. So I got y minus 12 equals negative 2 times positive 0.2. That together makes y minus 12 equal to negative 0.4. And then lastly, I just need to add the 12 over. Negative 0.4 plus 12. All right, when I think about this, okay, negative 0.4 plus 12, I know it's going to make a positive number. To figure out that number, I have to do 12 minus 0.4. And I get y is equal to 11.6. Therefore, I know h of 6.2 would be approximately equal to 11.6. So there's my estimation. Okay. Now it says it wants to know if we have an overestimate or underestimate. Okay. Well, that comes from this piece of information right here. That's the key piece of information there. H double prime of x is less than 0 for determining whether we have an overestimate or underestimate. Okay. So when we see that the second derivative here is negative, that tells us the concavity of h. We now know that h is concave down, right? So when we used our tangent line to approximate this, we can see our tangent line matches the graph of h at the x value of 6. But for any other number, whether we're going left or going right, our tangent line is always lying above the curve. So that means our guesses are always going to be overestimates. So here's what we can say for a correct explanation with justification. So I need to know why, I need to state why I know this thing is concave down. Okay, so I'm going to say since h double prime is less than 0, h must be concave down. Therefore, my answer of 11.6, right? I'm getting 11.6 from using the tangent line. That's too high compared to what h of 6.2 actually is, right? Therefore, 11.6 is an overestimate. Because the tangent line lies above the curve. Okay. So a couple of things that I'm going to be looking for. You need to know that it's concave down, but you got to tell me how you got there. So you can't just say since H is concave down. The problem never told you that H was concave down. The problem told you that H double prime is less than 0. But we know that that means concave down. So we need to just state that somewhere in there. We must state that our estimate is an overestimate because we know that if the graph is concave down, the tangent line lies above the curve. Okay, so let's move to problem 6. Problem 6 gets a little bit more challenging because I switch up the variables from x and y, which we're comfortable with, to w's and t's. Okay, so it says water is filling a pool. The amount of water w at time t equals 0 is 600 gallons. The function w of t is always increasing. Okay, so here's what we know. When t equals 0, w equals 600. That was given in that second sentence. They also told us that w of t is always increasing. Thirdly, they told us dw dt equals 1/20th w minus 100. Okay, so part A says, find the tangent line equation to w at t equals 0. Use the tangent line equation to estimate w of 1. Okay, so what we want to do is come up with a point here. Now, our point was given in that second sentence, right? We know that t equals 0. T is acting like x in this problem. W is going to act like y. So we know the point is 0, 600. Anytime I have letters other than x and y, when I write a point, I like to write t and w underneath, just so I keep them straight. So that's our point. My slope, then, I have to use the derivative to find. So what I'm going to do is I'm going to take dw dt, because the slope of my tangent line is always given by the derivative, and I'm going to plug in the point 0, 600. Now in problem 5, the problem before, there were both x values and y values to plug into. This one only has a w value. Just make sure you're plugging in 600 for w and not 0 for w, right? W is 600, 0 represents t. So I have 1/20th, and I have 600 minus 100. 600 minus 100 is 500. So this thing ends up being 500 over 20. I'm going to cross off 1 0 from h, because 50 divided by 2 is a much easier number to do. 50 divided by 2 without a calculator is easily 25. So that's my slope. Now I can write my equation. Y minus 600 equals 25, x minus 0. Now this is my tangent line equation. I'm going to get a point for doing that on the AP test. Now I just need to plug in what I'm estimating. I'm estimating w of 1. So I'm estimating, I'm going to sub in for x, I'm going to sub in 1. One minus 0 is 1. 1 times 25 is 25. And I'm going to add the 600 over, and I'm going to get y equals 625. But I'm not going to forget to write w of 1 then is approximately 625. And this is a problem that has units. That represents the gallons of water in the pool. Now, since we're filling up the pool, it should make sense that at time 1, there are more gallons of water in the pool than there are at time 0. If we would have gotten 500 something, right, or a number less than 600, we'd know that it's not right because we're filling the water, right? We're filling the pool with water. Okay. The next part is a little bit more complicated, and this is, if you have an issue, it's probably going to be here. says find the second derivative of w with respect to t and use it to explain whether your estimation in part A is an overestimate or underestimate. Okay, so this is just like question 4. We need to determine the concavity of w in order to answer the question whether our guess is too high or too low. So it's just a little bit not quite as straightforward how that works. So what I'm thinking in my head is I want to get the second derivative, and I want to be able to determine, is this a positive number or a negative number? Once I can get to that, then it's going to be easy. So before I do my second derivative, I want to rewrite my dw dt, so it's going to be easier to do a derivative. So I know I have this this equation right here as my first derivative. I'm just going to go ahead and distribute that to make this thing easier to deal with. When I distribute that, I get 1/20th w minus 5. Because 100 over 20 is 5. Okay, now I'm going to go ahead and do my second derivative. While at the same time remembering that this is implicit differentiation. So w is acting like y, so anytime I do a derivative of w, I need to tack on dw dt. So for my second derivative, I got to do the derivative of 1/20th w. That's obviously just 1/20th, but I have to tack on dw dt. Now, when we worked on implicit differentiation, what we often did is just took our dw dt, plugged it back in, and simplified, okay? But we can actually take a shortcut here. The piece of information that's going to help us in part B came up here. I'm going to scroll back up to it and circle it up here. W of t is always increasing. If w of t is always increasing, we know that an increasing function has a derivative that's positive. We know that from the test book for related rates. So right away, I know that dw dt has to be a positive number. Now, if dw dt is a positive number, right? This right here we know it has to be positive. This right here is a positive constant. A positive number times a positive number makes a positive number. So without even subbing back in for dw dt, right, I can say that this second derivative is always greater than 0. I'm definitely going to need to state that in my explanation here. One thing I want you to be aware of, it's okay to leave that dw dt in there as long as they didn't say solve for the second derivative in terms of w and t. If they said that, then we'd have to plug in what dw dt is. But they never said that, so we're going to stick with this because we can tell it very easily. So here comes my explanation. Since w of t is increasing, that was the piece of information they gave us. dw dt must be greater than 0. And if dw dt is greater than 0, in our setup up here, we know the second derivative is greater than 0 as well. So this is what we wanted to reach, right? Because now we know the concavity of the graph of w of t. So now we can say w of t is concave up. So in my graph, I know this is what w looks like. The tangent line I wrote now is clearly going to be too low of an estimate. So my guess of 625 gallons is an underestimate because the tangent line lies below the curve. and we're done. We answered it fully and completely with good explanations. So that's 4 and 6. We'll take a look at some other problems in the next video and in class on Wednesday. Take care, guys. 2 chains. Bye.